Is the speed of the particle increasing or decreasing at time equals 1?
Well, to figure that out, Duff, what we need to do is examine the relationship between velocity and acceleration on speed.
And really there are only 4 scenarios to deal with.
That's right, just 4 cases, and I think it'd be a good idea just to write all of those out. You could have positive velocity with positive acceleration.
This would result in the particle speeding up.
Right, both of those are headed in the same direction. You could have positive velocity with negative acceleration.
This is a situation in which the particle is going to slow down.
Right, they're headed in opposite directions and working against each other. You could have negative velocity with positive acceleration.
Right, again a situation in which the particle is going to slow down.
And lastly, you could have negative velocity with negative acceleration.
And in fact, I believe that is what we have in our problem.
Right, I think you're right, Duff, but just to be sure, let's look back at our graph. If you look at our graph, you can see that at t equals 1, we have negative velocity since the velocity is below the axis. We have negative acceleration because the slope at t equals 1 is negative. And from our answer to part B, it came out negative 0.176.
Great. So the perfect answer would be, since velocity and acceleration are both negative at time equals 1, the particle is speeding up.
Perfect. Let's move on to part D. Find the total distance that the particle traveled from t equals 0 to t equals 8.
So what we're really looking for is the exact number of total distance traveled to the left and to the right.
And then what we'll do is take those two numbers that we get and just add them together to get the total distance.
Great. So to go from our velocity graph to distance traveled, what we really need is the area under the curve.
We can explain how this works by making a little box underneath our curve and showing what units might be. In this side right here, this would be, say, the velocity measured in maybe meters per second. Along the top, this would be the time, maybe measured in seconds.
Right, and so to find the area of that, you would just go length times width, which in this case would be meters per second times second, resulting in meters as our distance unit.
In calculus, we have something that'll give us the area under the curve called the integral. For the portion where the particle is moving to the left, it'll be the integral from 0 to a of v of t dt. For the portion where the particle moved to the right, it'll be the integral from a to 8 of v of t dt.
And luckily our calculator will take care of these numbers for us.
Absolutely. Just go back to your graph, hit graph, then hit second, calculate. Number 7, where it says lower limit, type 0. Where it says upper limit, type alpha A, and hit enter.
Alpha A is that number that we stored from part A.
This will give us the distance that the particle moved to the left, negative 8.824. Do it one more time. Hit second, calculate. Number 7, from A for your lower limit to 8 for your upper limit. And this will give you the distance that the particle moved to the right, or 7.133.
So the particle moves a total distance left of 8.824, a total distance right of 7.133, and so the total distance traveled would be 15.957.
Now, Duff, it is possible to make our calculator give us this answer, 15.957, with just one integral. But you have to change your equation slightly. Go to y equals, and we need to insert absolute value bars here. What that'll do is take everything that's below the axis and shift it above the axis. To insert that, hit second and the delete key, and then hit math, scroll to the right and hit number. The number 1 is the absolute value key. Close your parentheses and just hit graph. And you'll see an identical graph just with positive velocity, but the same area under the curve. To find the area, hit second, calculate, number 7, and this time just one integral from 0 to 8.
You'll notice that in the end, once it's traced out the new areas, it'll give you the same exact answer as you got last time, 15.957.
You can write your answer either this way with 2 integrals and a total of 15.957, or just one integral from 0 to 8. But if you use one integral, don't forget your absolute value bars.
Fantastic. So this moves us on to part E. So E is find the farthest distance the particle is from the origin over interval t equals 0 to t equals 8.
To do this problem, we can use the integrals that we had from part D. Let's start by drawing a little picture of our particle. Remember that he starts out at t equals 0 at 5. The particle then moves left. The integral from 0 to a of v of t dt, which equals negative 8.824.
This actually causes the particle to move past the origin to the left all the way to negative 3.824.
Then the particle moves to the right, the integral from a to 8 of v of t dt, which equals 7.133.
This causes the particle to move to the right, past the origin again, and obtaining a final destination of 3.309.
Correct. If you look at our picture, you can see the furthest distance the particle ever is from the origin to the left is 3.824 spots. To the right, that's 5 units. So the particle is farthest from the origin at t equals 0, 5 units from the origin.
That's actually the perfect answer that you would need to represent on your paper.
Well, Duff, that wraps up our particle motion question.
Phil, what do you think the key to solving this problem was?
Well, definitely the relationship between the velocity graph and the motion of the particle. When the velocity was below the axis, the particle moved to the left. When the velocity was above the axis, the particle was moving to the right.
Yeah, I can see that. Having both of those graphs there, we use them in every single answer.
If you want to work a similar problem, you can go to our website, funyoumentals.com, and you'll find a problem that uses the skills that we used to work this problem.
Thank you very much for watching, and I hope this helps you on your AP exam.